Hello juniors, and welcome to Computer Systems and Programming. For this video we'll be talking about functions and how we actually make them in Python. So you've heard a lot about these. I've talked about them in many different ways with the print function, the input function, and in each one of your debugs you've had functions. So we've talked about these a lot. Now let's actually start using them in our coding. So the first thing you're going to do is open up Eclipse and make a project called functions. I already have one, but if you don't, you go File, New, PyDev Project, type the name in there and click Finish. Again, I have one. And then once you have your project folder, you're going to go onto Canvas and download the function outline.py, and you'll fill that out along with me as I'm going through this. I'm going to go File, New, PyDev Module, and call mine Practice. Practice. And you can follow along in your outline. So let's talk about the structure of functions. Now the syntax is as follows, and it's even more complex than all the other things we've done. So first you have define, or def, define, and then you put the function's name, or name of function, and then parentheses parameter. And we're going to explain all of these pieces once we get it all done. Then you're going to have a code block. Then you're going to have a return statement with a variable / data. So there's a lot of pieces in there. I want to break down the first piece, which is the name of function. Now there's a couple of rules that come along when you're naming a function. They always have to start with a letter, so start with letter. They should always follow camel casing, so that means that each letter of the first of each word should be capitalized. So name of function, so the O and the F are capitalized. They can be any length, but keep them as short as possible. As possible. They can have numbers, but it's not preferred. So you can throw numbers in there, but it gets kind of confusing if you have a function named this. And then finally, they can't be the same as any Python keywords. So they can't be print. And you can tell these keywords by typing them in, and they'll turn a different color. So print, true. What's another one? False. Any of those. Input. Input might work. But any Python keyword, no keywords. You can't have those in there. So those are just a couple of the rules when you're using these functions. You got to name these in a way that Python allows for it. So let's actually do some example. Let's make a function that will add two variables that are inputted. So we'll define sum2 nums. That's the name of our function. And you can tell because it turns that bright yellow color. Your color might be different. It depends on what theme you have, but it will change colors. Then we'll add our parameters, num1 and num2. And then we're going to go into the code block, and we're going to say sum equals num1 plus num2. And then we're going to return, put our return statement, sum. So now that we have some actual things put in here, let's talk about what all these different pieces are. So sum2nums, that's the name of the function, and it follows all the rules as well as the camel casing and such. Additionally, we have our two parameters. So parameters are separated by commas. So you can have tons of parameters, as many as you want. You just have to separate them by commas. This function has two parameters. One is named num1 and another is named num2. You can think about parameters as variables for functions. So parameters are just these variables that are only working for this function. So once you leave this code block, num1 and num2, they don't exist. So they're kind of these variables that are only used in the function. Additionally, what parameters allow you to do is bring stuff in. So when someone uses this function, they have to provide num1 and num2. So they have to provide these variables. So with our function that we have, we'll have to pass two variables. And they say num in it, so we know that they're integers, or we're guessing that they're integers, so we're going to pass two integers. So once the function is called, it will sum the two numbers. It'll add num1 and num2 together and store that in a variable called sum. Then the function returns sum. And what return does is it just brings back the function to where it was called. But what is this call? I keep saying call a function. How do we call a function, and what does that mean? So calling a function is what we do to run the function. Because if we run this code just like this, whoops, that's the last code I was working on. If we run as, whoops, make sure we're clicked on it, run as, Python run, nothing happens because we never called this function. So to call the function, we have to type the name of the function and the parentheses with all the parameters that we need. So for us, we would say sum to num, and look, it provides us with it gives us a shortcut, so we can click on that or click enter. And now we have to put in the two parameters. Num1 will put 3 and num2 will put 4. Now, again, we'll run this, but nothing will happen because we're just calling this function, and there's no print statements or anything, so nothing will happen once it's inside of this. So now this line replaces num1 and num2 with these parameters that we put in here. So it's going to call this function, it's going to call sum two numbers with replacing num1 with 3 and num2 with 4. Then it'll add those two together and return it. We could also put in actual variables into the for the parameters. So we could say x equals 2 and y equals 3, and if we put x and y in here, this is the same thing, different numbers, but instead we're sending in our variables. So num1 would be x, which is 2, and num2 will be y, which is 3. So we're just passing along the data from this variable to num1, and then this will access that. So when we call this function, it's going to return something. We see that it returns sum, so we have to catch whatever it returns. So whenever we call it, we have to add a variable to catch it. So this line will call this function, sum the two numbers together, return the sum to this highlighted spot, and then it'll make num equal to sum. So this is a lot of roundabout, but let's just run this and see what happens. Run as Python run, and it prints 5. So what actually happens is, if we go into debugging mode, and let's close this, let's run this in debug. Whoops. Let's add a breakpoint at the beginning of this, at this first line right here. Let's run it. So it's made the function, and it's making the variable x, and you see that it made the variable x. It's making the variable y, so y is 3, x is 2. Then it's going to go into this function, and it's going to say num1 plus num2 is going to be 5. So sum is 5. And then it's going to return sum. So it's going to go back to this line right here, and it's going to say the return value of sum2nums is 5. So this right here, this value is 5. And then it's going to make num equal to 5. And then it moves down to the next line, which is print num. Num equals 5. And so it prints out 5. Again, it's kind of weird to see it kind of step through this, but we're calling this function, and it's replacing num1 and num2 with x and y, and then printing out this num. This doesn't seem very helpful, but when we have to add two numbers tons of times, it may be helpful, because then all you have to do is type this and the two numbers that you want to add together. This is a bad example because it's not very hard to sum two numbers. You just put x plus y, and boom, you already have the sum together. But with other functions, like the ones you've seen in our previous debugging, those are actually helpful, and they do some service. So let's go through another example, and this one will have the function print out a list. So let's define a function print list. List. And then let's put our parentheses and our parameter, which is list. We're going to send in a list, and we're going to say for x in list, print x. Print x, and then return. Now, let me put a little bit in between there. So, this function has one parameter. It's just list, and it has nothing returned. Nothing gets returned. It just does whatever it does, and then returns back to the same line that it was called. So, let's actually call this function. Let's make a list, and let's set it up to 3 strings. String, and then let's call it print list. So now it's weird because we have all these things named the same thing. Let's change this to A or something. Now we have this list A. It's going to get sent in to here and replace this. And so then for x in list, it's going to print x and then return. So if we run this, it's just going to print out string, because it's sent, these two lines send the list, send A into here, and then it goes through that list for x in list, and list is A. It prints out each item within it. Now it's confusing with functions because it changes when you go to the function. This list that was called A out here is now called list in the function. But it's nice because now we can send any type of list in here and it'll print it out. So let's make another list, B, and let's just make a list of Boolean, true, false, and then let's print list B. And if we run this one, again, it'll print the 3 strings, string, but then it'll also print true, false, because that's what the function does. It just prints out each of the items in the list. So this is helpful if you're this specific function is helpful if you're going through a bunch of lists and need to print them out. But sometimes you just need to change them a little bit. So you need to edit the insides of it. One of the examples that I had from my programming is if you needed to change every item in a list to nothing. This is a common thing, but if you do this, at the end, each list will equal nothing because it just it changes all of them. So that's helpful if you're trying to return that list and have it just be empty. So this gets at the whole point of functions, which is to reduce repetition code. instead of having to write this code for each list we have here, all we have to write is print list, and it'll print out that list. So it makes the amount of code that we have to do way less. So if you have a program where you're constantly printing out lists, this would be a useful function, because you wouldn't have to make a for loop for each list. Instead, you would just call this function and it would print everything out. Now, this is a simple example, so it might not seem helpful. When am I going to need to print out a bunch of lists? But when we make more complex functions, they really do help. Additionally, it helps us organize our code, because it stays into these nice sections, and you can see when you're reading the code, oh, it's just printing this list. You know exactly what this whole line does just by reading this one thing. It's going to print list B. It's going to print that list called B, the variable B. So now there's a couple more things that you need to understand about functions. One, I actually did it wrong, but all functions need to be at the top of your program. So any functions you make, like this, needs to be at the top of your at the top of your program. So you always make any functions you need, then you start coding the program. So this is a little different because we're just using random examples, but if the code is after this, so let's remove this again, and let's move it to after this list is called. If we run this, it's going to say print list, name print list is not defined, because the program tries to go down and read through all of it. It tries to do it line by line. And since it gets to this before the list is even made, it gets confused and throws an error. So it's a good practice to put all of your lists right at the top. That way, whenever you use them, if you use them at different points in the program, they'll always be below the functions, and it'll always work. So again, if you want to add functions, always add them to the top, because the program reads top down. So to use the functions, it has to be created first. It's the same way as if you make a variable, you have to make the variable before you use the variable. Another thing you need to understand about function is you always need to add a comment before your functions that explains what it does. So this is because functions can be complex. So having something that simply explains what the function does can make it easier for someone trying to understand your program. So let's add some comments to our functions. If we go to this sum2nums, we can add a comment. We can say this function takes in 2 integer parameters and adds them together. Then I'm gonna enter. You gotta manually enter unless you have wrap text on. Then it returns the sum of the parameters. So that gives a clear and concise definition of what this function does. It takes in 2 parameters and adds them together. Then it returns the sum of the 2 parameters. So it tells you what the function takes in, what kind of parameters it has, and it tells you what kind they are, integers. And then it tells you what the program returns. And if we wanted to even be more precise, we know that since it's the sum, it's going to be an integer, because 2 integers add together an integer. But you could also say returns an integer, which is the sum of the parameters. Now let's move on to the next program, or the next function, and write a comment for this. This function takes a list parameter and prints out the contents of the list. It doesn't return anything. So again, this definition gives a clear, concise way of understanding this function. takes in a list parameter and it prints out everything that's within that list. And it doesn't return anything. It just prints out what's all in there. So to sum up these comments, each one should say what the parameters are, what the function does, and what the function returns. So it's kind of 3 sentences. I'll just put this in like this so that you can read. But the comment above the function needs to have what are the parameters, what does the function do, and finally, what does the function return? Because that's 3 different points of information that are really helpful for understanding functions. And if you wanted to, you don't have to format it like I did as well. You could put it like this: parameters, function purpose, and return. And then it'll just give you, then you can say, and actually I'll do this in this one because this has each of the pieces. But if I were to do this alternate way of writing it, with this one, I would say 2 integer variables sums the parameters together, and it returns a integer sum of the parameters. And there you go. So this is an alternate way of writing this. Either way, you just need to have these 3 points of information. What are the parameters? What does the function do? And what does the function return? Finally, the last thing you need to understand about functions is that they don't need parameters or they don't need to return anything. So like you saw with this, it doesn't need to have anything, and you don't need to have parameters. It's just typical that you have parameters. It's not a requirement. It's typical because normally with functions, you want to do the same thing to different data. So it's helpful to have parameters to insert different data. But there are sometimes functions that you have that don't actually do that. An example could be if you wanted a function that prints out all the instructions for the beginning of a game. You don't want to do that you don't need to do that a lot, so you just make one function that does it, and you can just call that function. The same goes for returning variables. You don't always need to return a variable, but you always need the return statement. No matter whether you're returning it or whether you're returning something or nothing, you always need a return statement because it tells the program when the function ends. Another thing to keep in mind, and just reminder of all this, is these are just like if blocks and loop blocks. They need to be tabbed in. Functions need to be tabbed in, otherwise they will not work. It's just like the if block, just like the while block, and just like the for loop block. So now that we've kind of covered how to make functions, what they do, their purpose, let's talk about errors. So remember, an error is a bug or something that went wrong with the program. There are 2 types of errors: syntax errors, which means that there's a problem with the program's syntax, or logical error, which means that there's a problem with the program's logic. Again, here's the syntax, the basic syntax for a function. You've got the name of the function, the parameters, the code block, and then a return statement plus some variable or data. Remember that you don't need to return like I said, this is a variable or data, so you could put a number here, but that doesn't really helpful when you're trying to sum and return something that is useful. But back to the errors. When we're talking about common syntax errors, mistyping the keywords like define, that will cause an error, and you'll see the colors have changed and an error will pop up because it won't understand what that code is doing. See, It says it's expecting something. It doesn't know what, but it's expecting a letter. You could be missing a parentheses around the parameter, so that messes it up a little bit. You could be missing the colon. That's a very common error that people forget. And you could not have the code block tabbed in, which would cause another error. So for logic errors, again, just like all the previous units, there aren't common logic errors because it depends case by case. But the logic errors are normally some problems with the function's logic, which means that the function doesn't do what it's supposed to do. The best way to check for these logical errors is to read the comments and find out what the function is supposed to do, and then look at what it actually does. So if we look at this function, let's just say we put a minus sign instead of a plus. We can see that the program is supposed to sum the parameters together. If we look at this program or this function, it has a minus, which isn't what you use for summing. So you know that that's the logical error, and you can change it to a plus. So again, it depends on function, but logical errors are best found by reading the description of the function and seeing what it's supposed to do, and seeing whether this code actually does what it's supposed to do. So this sums these two numbers together, and that's what it says to do. So that's what you're going to do. So with all of this, you should have had an example for your outline activity. So if you haven't, go back to this video, finish your function outline.py, and then you're going to submit it on Canvas following the GitHub submission process. Then once you finish this outline, you're going to move on to the function drills, and you'll submit it in this function drills activity prompt. Let's take a look at these real quick. You're just going to go through and do just like all the other ones. You're going to get a task, define a function that has two parameters, and make a function that adds the two numbers together, and then add two numbers, the sum of the two numbers, and returns it. So you're just going to go down and make all of the different functions as well as calling them. Now call the function. Make sure you call it on each one and print out what the function returns. You can do this two ways, like this, how we have the print. We save it in a variable and then print that variable. Or you could just print it and say, and put the actual call. Whoops. Copy this. This line 50 or 45 and 42 and 43, these two things do the same thing. It just prints out the sum of x and y. One does it with a variable in between, and one does it with no variables. For this one, you can do it in either way. Return the result, call the function. So you can do it by either storing the function's results in a variable and then printing that variable, or you can just print the results right away, just like this line. So you only have 9 of these, so go ahead and go through that. Once you finish, you'll submit on the activity prompt. Then you'll move on to the debug drills. For the debug, again, you're going to have these functions. You're going to get these functions, and each one is going to have errors. Now for this one, these are a little bit different from all of our other debugs, because now we're actually using the functions. So the problem starts after this line and ends after this line. So the error is somewhere between these two lines for this one. So there's 4 errors in all of this highlighted text. Whoops. In all of this highlighted text. And then there's 5 errors in all of this highlighted text. Now you're not just going to pay attention to the stuff inside, but also the calls to the function and the defining the function. The comment will tell you what the function is actually supposed to do. So this tells you the actual correct thing that the function is supposed to do. The function may or may not do that. You have to look at this and look at this and see, is that doing that? Is this first step converting ounces to cups? And it kind of gives you these comments along the way to help you out. If you don't remember how to do this type of calculations like conversions, just look up conversion charts online, and that will be helpful for trying to calculate these different conversions. But they're not supposed to be super complex. You should be able to identify these errors, these logical errors, fairly simply. Any syntax errors, you'll have to pay attention for the problems with the program's typing. Then once you finish this, you're going to submit it on the debug drills activity prompt following the GitHub submission process. Finally, if none of that makes sense to you, or let's say you want more examples, we have our exercises. If you just need a written version of everything I just said, you have the programming manual. And if you just don't like the way that I teach, you can go to W3 Schools or Tutorials Point to learn a little bit more about functions and how they work. If you have any questions, you can always reach out to your instructor. Otherwise, juniors, I will see you later.